So I'm recording this just so that anybody who misses it can see it. But I want you up top to write the photosynthesis equation right here. Here we are. Photosynthesis equation. Let me rewrite it. But it's going to be, write it nice and big this time, Mr. Dayton. Come on.
I already had the first part down, so it was pretty good for me.
We have 6 molecules
Yeah.
of H2O
Plus.
plus 6 molecules of carbon dioxide. Okay. Oh, it's so blurry.
Oh my god. It's super blurry. Oh my god. This is blurry as my vision when I look at it underwater. Maybe because it's far away.
Oh, there we go. 6 molecules of carbon dioxide. You're gonna, eventually this is going to create something over here. This is going to create glucose. That'd be C6H12O6.
Why do you know this?
And
Why don't you?
6 molecules of oxygen. Now, this doesn't have to happen in just increments of 6 molecules. This is the base equation that we go with. All right. Now, I'm forgetting one important thing, aren't I? I only have 2 reactants and 2 products. What am I forgetting here? Yeah, chlorophyll is necessary, and what else?
Light.
Light. Very good. So that's where you kind of come in with this little lightning-ish bolt.
It's a squiggly.
The squiggly, and that's the light, sunlight.
Oh.
The sunlight is affecting the chlorophyll, and that's what we just saw. Okay, so those are the 3 reactants and the 2 products. Okay, now I'm going to write down what the products actually are, so you don't just look at these and be like, huh? Okay, H2O, what is that, everybody?
Water.
Water. This is water. What is CO2, everybody?
Carbon dioxide.
Carbon dioxide.
Carbon dioxide if you want it.
No.
Darn.
Sunlight and chlorophyll is already written. What's C6H12O6?
I don't know.
Hydrogen?
No, not hydrogen. It contains some hydrogen.
Some.
What's that? Who said it? Glucose. You can write this a number of ways. Glucose, or sugar, or food for the plant. Okay, that's its food. That's its product. That's what it wants to make, correct? And then we have over here a waste product or a byproduct. What is this?
Oxygen.
Oxygen. So remember what the guy said in there. Is our plants just nice?
No.
No. That's a waste product. They don't just say, oh, there's all these humans and things that
Let's give them
need to breathe oxygen. Let's give them oxygen.
So we're just
Not really.
breathing their farts.
Yeah, there you go.
Oh.
Breathing in plant fart.
You have to say that. Just made life.
So this is the equation. Got it? Good. Everyone have this equation?
We're breathing started. Plants started the apocalypse. I don't want to breathe ever again. Started the apocalypse.
All right. So we're going to break this down a little bit. Okay. We're going to start with the light reactions. So you're going to have to draw this diagram with me while I draw it.
We will. Okay, let's draw.
Yes.
No.
First, we have our H2O.
Wiggly.
Right?
Box. Right.
This light. The squiggly is the light. That light energizes
Or does it?
and splits
Okay, that works.
H2O.
Oh.
Remember that part when he talked about it? Probably not. You probably had to write down.
I
You
remember.
were like, this is insane. I don't need to know this. Okay, so the light energizes and splits that H2O. What's it going to split into? Yeah, Avery.
hydrogen
Yeah.
and there. I want to say oxygen, but I know it's not oxygen. It was.
Why not?
Because I remember there being a different one. It wasn't-
No, you're absolutely correct.
Oh, then it's oxygen.
It's oxygen. Okay. So, yep.
Confused every
With multiple molecules, we have two H's, right? HH, and an O. And if two of those molecules get together, two atoms of oxygen get together, it becomes O2, which becomes oxygen. So that's the easy one, the first part. The O is here, the H's are here. Okay, the O, what does that do?
It oxidizes.
Yeah. Yeah, it gives us air. It's waste immediately. It's no longer needed for the plant. So you can go exactly like this. Take this, make a nice long arrow here. Oxygen is a byproduct or waste or garbage.
Oh, so me. Oh.
Okay,
According to-
it's garbage for the plant. Doesn't need it. So we are left with the two hydrogen molecules. Everybody with me here so far?
No.
Okay,
Yes.
oxygen is waste. This is part of only from the water being energized by light.
I got lost 17 steps ago.
Now we're gonna go with one of these hydrogen molecules. Split it even further.
Why? I
No,
don't want
you
to
did.
split into You did. You are hydrogen peroxide.
You're left with H plus, which is a proton, right?
Yes.
Who remembers talking about protons and neutrons last year?
No.
Yeah, a little bit. Okay. So this is H plus and an electron. An electron is charged what? Negatively or positively?
Negatively.
Electron is
Negative.
negative. Yep.
Negative.
Electrons are negatively charged and protons are positively charged. So what happens here? Light splits. Ooh, I gotta make sure I have my correct terminology here. Splits
Can I split? Because I can't do the splits.
an electron
I'm being serious.
from the hydrogen. So now we're left with a hydrogen ion, which is positively charged, and the electron, which is negatively charged. They're
Yeah.
apart from each other.
Totally.
This is light. Light does some crazy things. Sunlight.
What about it? You gotta put-
This is all taking place in the thylakoid, you need to remember.
No, we call it acid.
So he talked about the electron transport chain, excuse me. That electron going through those proteins, and it's giving energy to the thylakoid. All right, we're gonna do it like this.
No.
The stairs.
No.
Make stairs for this electron to go down.
Oh, so it's trying to split again, but it can't. So he's going to sell his soul. Oh,
Here's the way you gotta think of it. Electrons have so much energy.
just like I do.
Yes.
No, you're an alien. I just want to cry. Why? Because of all my terrible jokes.
Okay, it needs to expend some of that energy by leaving in steps.
Yes, it really should.
It's over here.
E minus. Wow, I didn't even know that was a grade.
Well, it's a grade above that.
Yeah, heaven's the eighth.
It's
Just
above
like,
average.
I'm going to say this is.
And then there's the O for
Your opinion is bad.
and then my.
Hippity hop. I
And
think the
then my
O stands for
favorite-
over. No, it's.
Mine.
Okay, so here's how you think of it, or I think of it. Imagine
No. Or something like that.
this electron is so energetic. What would happen if it just fell down the stairs?
I
Get hurt, right? Yeah, get hurt. So think about it this way. This electron has so much energy that it needs to leave in steps. It goes through that electron transport chain, and that's what he went through. And that's where it can move a little bit more safely. Think of it that way. Okay, the electron is moving in steps.
What if it's
Okay,
a
'cause it has
reckless
so much-
electron?
Yeah, it's reckless. So it needs to do this. It understands that it's reckless. It's going down the steps. Okay,
Still-
and the hydrogen is gonna meet back up with it.
Do we even have steps now in school? Like,
I'm a bulldog.
do we even have a second floor?
Do we have a basement?
No.
No.
We have
Well, I know
zero
we have a
students.
No, our school is like lower now.
I've got it up.
We have
Elementary.
So it's losing its energy as it goes. Okay, losing its energy as it goes. Then it's gonna bind back up with this H. See this H is met it again? They're gonna bind back up. I made a little heart there.
Best of
Okay,
friends.
So the energy, the electron lost its energy. Okay? And it binds back with the H.
I don't want to see the dark heart.
My heart looks like some.
Can we make it?
Wait.
My heart looks like a peach.
My heart is a circle.
Yeah, we put hearts down on it. I crushed my own heart.
Okay, let's get that part drawn.
Very nice.
So we've split this water into hydrogen and oxygen. Oxygen is a waste.
Breathe in the oxygen.
So the oxygen goes out right away. So when we draw this on the quiz on Friday, I want you to know that oxygen is a byproduct. It's waste. Right away, get it out of there. And you're left with the hydrogen. The hydrogen then splits even further into a hydrogen ion and an electron. The electron has to split, lose some of its energy because it's so energetic. Comes back and it's going to bind with that hydrogen again. Okay? And then this is going to eventually have to go to the dark reactions. We're still in the light reactions. These are the light reactions. Okay, so all of this.
Tiny explosion.
What about the Kelvins?
Yep, we're gonna get to the Kelvin cycle.
No.
Not today,
Why
but
did you?
tomorrow.
Good.
Well, the Kelvin cycle is the dark cycle. so-
Yes.
The dark cycle is the Satan cycle.
No, it's the Kelvin cycle.
It's the
No, it's
mean.
not the dark cycle because he's selling his soul to the devil.
No, it's.
This is all taking place in the thylakoid. So here's what you have to imagine. Okay, they're getting on this bus. This is where people lose me.
Okay,
We're ready.
Are you trying to draw?
Yep, here's my school bus.
School
Gotta draw the bus.
Oh my
Miss Frizzle.
Jump back.
Take the left here.
Can we have
Okay.
No way.
So this H and the E, the hydrogen, is back on the bus. Okay, this bus over here. We're gonna have our.
I don't have enough room.
Okay.
Well, that sounds like a
No,
problem.
Where he at?
I haven't even used half my paper. Yeah, the bus is
I
so
am tired.
boring.
Looking drawing it big, so.
Okay, it's on the bus.
Oh my god.
Alvin, soup, bus.
The bus, remember, we didn't even get to the dark reactions. We didn't even get to the Kelvin cycle. This bus is going to use that energy from the electron to drop off the positively charged hydrogen. Bus uses energy.
Because the bus is not a gas, it's electric. Shut up! No one gets the joke. I was thinking Mario Kart.
Oh.
Oh, wait!
Okay, it needs to drop off hydrogen. Okay, it's going to need to drop off that hydrogen. We're only breaking down the water so far. That carbon dioxide is going to be used in the Kelvin cycle. Remember they talked about photo and synthesis? Photo means light. Synthesis means a product, making a product. Okay, that's where it all gets put together in an assembly line, the Kelvin cycle. Okay, so
Kevin cycle.
now
It's the meat.
It's electric. It's an actual song. It's not from this.
the bus will go back.
Yes, that was the joke. I know. You said the bus needs electricity, so it's electric.
I said I get it.
the bus goes back
What is that actually?
But do I need to draw another bus?
to pick
I'm trying.
up.
Okay, what is that song?
It's called a song.
Just do something.
Pick up more H.
I don't know.
Okay, and then it continues this. It's gonna continue happening. Okay, it continues happening and keeps dropping off H at the Calvin cycle. Calvin cycle needs that H so that it can create the food. We have not even gotten to the carbon dioxide. So if you want to enter this,
That means the electron is slowly again.
yep, and it'll bind again. Yep. So the carbon
I
dioxide,
don't know.
remember, the light reactions take place in the thylakoids. The carbon dioxide, where is this? We've already taken care of this, right? X that part out. We've X'd that part out. Okay, we still haven't even touched this. When does the carbon dioxide come into play? Okay, carbon dioxide comes into play. It does not go into the thylakoids. It goes into the Calvin cycle. It is immediately taken in through the leaves. Okay, carbon dioxide is taken in through the leaves in the stoma. Okay, and then that is where it's going to take place in the Calvin cycle. And that's what you have from there. So, I know this is a lot. Does everybody at least have this drawn so far?
Yes.
Okay, now, I know.
Yes.
The long and the short of it, the short story is those three reactants make these two products. We're breaking it down on kind of a molecular level, okay, so that you understand.